Hi, lovely people. Today we're going to talk about grade 5, mission 6, lesson 4. It's a word problem. All right, let's see what they want us to do. We're going to use strategy, read, draw, and write. Violet and Magnolia are shopping for boxes to organize the materials for their design company. Magnolia wants to get smaller boxes, which measure 16 inches by 10 inches and by 7 inches. Or we can say 16 inches times 10 times 7 inches. Violet wants to get large boxes, which measure 32 inches, 20 inches, and 14 inches. The question is, how many small boxes will equal the volume of 4 large boxes? So before we found four, how many small boxes will fit in a 4 large box, we have to think how much will smaller box fit in a 1 larger box. That's the first goal that we need to figure it out. So we read question, and now we're going to go again to go and see what information we have. It says that Magnolia's small box measures 16 by 10 by 7. So let's draw the box. That's going to be our first thing. If I make a square, let's see, 1 inch square. Okay, I can create, I'm going to use my little triangle to make really good measurement. I really needed my parallel lines, so I can use that and my picture will look better, right? So from 1 square, I can create a box by adding 3 diagonal lines that are parallel to each other. And then I can also make these parallel lines to create the back edge of the box, and then also parallel line to do this. So far, this is a box that represents, now we need to label. So the length of this is 16 inches. Okay, and then it's 10 inches. And it's 7 inches. So we don't, it's not a cube, but I draw it like a cube, but it's really the dimensions are not the same. Otherwise it would be a cube. It looks like a cube, but it's not. It's a prism, 16 by 10 by 7. Okay. Now, then they say Violet wants to get a larger box, which measure 32, 20, and 14. When we know the 32, we can think, oh, 16 and 16 makes 32. And then we can look 10 and 10 makes 20. And 7 and 7 makes 14. So double 7 is 14, double 10 is 20, and double 16 is 32. So that tells you that each dimension of the length, the width, and height is doubled in a big box. So how we can represent that, I'm going to go down a little bit, and let's see, I'm going to make a bigger box. Let's see if I take this And I'm going to use also, okay, my ruler, make parallel. Let's see if I do like that. Let's see. Can do this. All right. Okay. All right. Gonna make. Now I'm gonna do these lines. I'm not gonna go over the board, just too close to the edge, so I'm not touching the letters there. All right. So parallel lines, and I can create my maker box. I also need to do this. So as you can see, this length here has to be congruent to the length on the bottom. So you can go all the way till then it matches, right? Okay. So I created a smaller box and large box. So now I need a label. This is length is 32 inches and this width is 20 inches and the height is 14 inches. Okay. So when we know this, we can see that, okay, so each dimension of this is twice this. So that means I can make a half of each dimension, and it will help me to see how many boxes would be in this. So if I make a half here and half here, all that I can create actually and show you exactly how many of these smaller boxes can fit in this one just by creating the visual of each length, half of each length, so I can create imaginary box. They're gonna be in this large box. So when we connect these, right, and then half of that, okay, half of that, about, so the parallel line. Here you go. I created how many boxes of the smaller size can be in this large box. As you can see, the base, the bottom should have 1, 2, 3, 4 boxes. And then you can know because it's a top layer is 1, 2, 3, 4 boxes. So 4 on the top and 4 on the bottom because it has to have a base. That means that 8 boxes of these can fit in a large. So that means that volume of this is 8 times greater than volume of this. So how we can prove it? We know that each of these volume is twice bigger. So it's 2 times 2 times 2. Twice bigger, twice bigger, twice bigger makes 8 times greater. So we can say that each dimension of each large box is twice bigger than dimension in a small box. So the volume of the large box is 8 times as great as the small box. But that was not a question. I can that was just how many of what is the wall, how many of these boxes can fit in this. Our question, it says how many smaller box can equal to volume of 4 large boxes. So now if we know that one box, it's 8 times greater than this. So 4 like this would be 4 times 8. That's how we're going to figure it out. So we can say that 4 large boxes times 8 will give us a volume of how many smaller boxes will fit in 4 larger boxes. So we know 4 times 8. If you don't know what 4 times 8 is, let me make it smaller a little bit, all right? Let's see, you need to do 4 times 8 and you don't know what it is. Okay, you have different choices. You can think of this, decompose 4 into 2 times 8. If you know what 2 times 8, 8 plus 8 is 16. And again, 2 times 8, that's 16. So now 16 plus 16 is 32, correct? So what is 4 times 8 is 32. So 32 smaller boxes will be in 8 large boxes. And now our job is to do answer our question in writing, because we read, we draw, and we write. How many smaller boxes will equal to volume of 4 large boxes? So we can say 32 small boxes will equal the volume of 4 large boxes. So now we, didn't. Okay, 32 small boxes will equal to the volume of 4 large boxes. And that will conclude this question. If you needed to imagine this, I can also make a little, I don't know how, that maybe something like that you can imagine. That is you can see these boxes visually. And then that would be the next there. Eureka. Okay. So this would represent the bottom layer of this, if you look. And then this is one box on, you can even color it if you like that. So 8 like this boxes will be in one big box, and 32 will be in 4 boxes like this. All right, guys, I hope you like it. Here is all, I'm gonna make it smaller. Oops, again, and thank you for listening. Goodbye.